Welcome to solverfy.
All right, so for a strong acid to strong base titration, for the initial pH, let's take a look at what the flask looks like at the beginning, or beaker as I've drawn. Inside, we just have the strong acid, and since no strong base has been added yet, this will be quite a bit less. Whoops. It will be quite a bit lower than a pH of 7. Okay. And for a weak acid to strong base titration, if we take a look again at the beaker, all that's inside of it right now is a weak acid. And so it would be very, very close to a pH of 7 initially. And for a strong acid to weak base titration, all that we have in here is there's only weak base present in here. So it's very, very close to 7 as well. It'd be slightly above 7, but very, very close to 7. So the order for the initial pH is strong acid to strong base is lower than, less than, the weak acid to strong base, which is lower than the strong acid to weak base. Okay, and that's for the initial pH. Now we'll go back up and start here with the strong acid to strong base titration for part B. So at the equivalence point, all the acids are neutralized by the added base. So the number of moles of the added hydronium ions equals the number of moles of hydroxide ions. So H3O plus equals OH minus, okay? At equivalence point of the strong acid to strong base titration, the solution consists of the anion of strong acid and the cation of strong base, which does not react with water. Hence, this solution is neutral. Since these are equal, it is neutral at a pH of 7. Okay? So then for the weak acid to strong base titration, the solution consists of the cation of strong base and the anion of the weak acid. So the strong base cation does not react with water. The anion of the weak acid acts as a weak base and accepts a proton from water and yields hydroxide. Hence, this solution is basic at equivalence point. Another way to put that is I'll just say the strong base here, it does not react with water. But the weak acid will. And it produces hydroxide because it's a weak acid, so it produces, whoops, fix that. It produces more hydroxide ions in the water, and so it makes it slightly basic. Okay. Now for the strong acid to weak base titration, at equivalence point, the solution consists of the anion of strong acid and the cation of weak base. Strong acid anion does not react with water. the cation of the weak base acts as a weak acid and donates a proton to water. And it yields H3O+. Okay, so at the equivalence point, that makes this slightly acidic. So that means it goes, the order for this one is strong acid, weak base is less than strong acid to strong base, which is less than the weak acid to strong base for the equivalence point.